Hey there, ladies and gentlemen. This is section 5.6, the last part of chapter 5. This is where we're going to start doing a couple of what I hope to be fairly interesting labs based off of the next couple of videos. We're going to talk about one more unit. It's almost the last unit that we're going to be dealing with in Chem 11, I think, about molarity. Molarity is concentration, and you've heard of concentration before. To put in kind of weird terms, molarity is when you take one thing, and we call that a solute, and you dissolve it in another, and we call that a solvent. So a solute gets dissolved in a solvent, and then these two things added up make a solution. Okay, that solution can be a variety of things. We'll talk a lot more about that in class tomorrow. And you can calculate concentration in a lot of different ways, but we use molarity. And molarity has a very simple formula, and it has some very simple units. Molarity is basically moles per liter. You take moles of your solute divided by liters of your total solvent. It has to be in liters, and then you get molarity, which has the symbol big M. So let's just try a few of these things, and you're going to see how straightforward this is, and you're going to be applying this in a lab tomorrow. So you have to find molarity. Molarity is big M, which is moles over liters. So you need two things. You need moles and you need liters. Well, it says you have 10 grams of NaCl in 500 milliliters of water. So there's your volume. You need to find moles. So you got to convert grams into moles. 10.0 grams. You want moles on top. NaCl weighs 58.5 grams. 10 divided by 58.5 is 0.1709 moles. Well, you need moles per liter. We have 500 mils, so 500 mils into liters. You can simply do this in your head. Gives you 0.5000. Divide those numbers out. Round to the least number of sig figs, which is 3. 0.342 big M. So that is the concentration of salt in solution. You guys can try this next one, or we'll do this one tomorrow. The main reason why you will be learning about molarity is to make solutions. You're going to be doing a couple labs where you're going to have to make your own solution, and you're going to have to find the concentration of a variety of things. So whenever there's a question, or if someone's asking you to make a molar solution, you just got to tell yourself that you're basically finding grams. So how many grams of solute do you need to weigh to make that solution? Okay, so we're going to work backwards from the first example that I just did. We need to find grams. So if big M is moles over liters, you can rearrange that to get liters times molarity equals moles. And then from moles, you can convert into grams. So we have liters and molarity in the question. 0.500 liters times 0.400 molar gives us moles. And 0.5 times 0.4, if I don't have a calculator, should be 0.2. So now that we know the moles is 0.200, we have to convert it into grams. To convert it into grams, we need to multiply it by its molar mass. This molecule, KBr, has a mass of 119.0 grams over 1 mole. 0.2 times 119, I have this number written down, is 23.8. This is how many grams of KBr is in that solution. What we are going to do tomorrow is we're going to figure out how many grams it takes to make that solution, and we're going to review or learn for the first time how to make a molar solution, and you are going to be in charge of making a few solutions for your upcoming labs. This can either be an unbelievably fun activity or a complete disaster. We will soon find out. There is another type of molarity formula that deals with dilutions. Now, dilutions is when you mix two different solutions together. So when you mix two different solutions together, they're going to dilute each other, and we need to find the new molarity after mixing. Okay, so this equation has 4 parts. Certain parts for the solution number 1 and certain parts for solution number 2. So when you look at this question, you're going to be given 3 out of those 4 parts, and you need to solve for the 4th part, and it can be anything really. So in my first example, here is the first solution, 300 mils of 0.15 molar calcium carbonate, and you're going to add it to 100 mils of water. We need to solve for the new concentration. So I always like writing out the equation, M1V1 equals M2V2. Molarity 1 and volume 1 is the original thing that you're starting with. So the original molarity is 0.15. The original volume of it is 300.0. This question wants us to solve for the new concentration. The new concentration is the new molarity, new M2. And the new volume is always the total volume after you're done mixing. So 300 plus 100 is 400. It's really the only mistake people make when starting off in this section is they always forget to add up the volumes. So in your calculator, you're just going to simply say 0.15 times 300 divided by 400, and you're going to get a new concentration of 0.1125 molar. Again, we got to pay attention to sig figs. In this question, the least number of sig figs is 2. So the final answer is going to be 0.11 molar. This question says, how many liters of that thing is required to make this and this? So if you're making these things, this is your 2, and this is your 1. So this is what you're trying to get at the end, and this is what you're using to start with. So again, I like writing down my formula, M1V1, M2V2. My initial molarity is 15.4. My initial volume is what I'm solving for. My new molarity that I'm trying to make is 0.375. And my new volume I'm trying to make is 2.50 liters. So 0.375 times 2.5 divided by 15.4 gives me 0.0608 liters. Now, most of the time you're going to measure out milliliters. You'll be doing that in a lab the next day. So times this by 1,000, you get 60.87 milliliters. Okay? So we'll see everybody tomorrow. Bye-bye.